now that we have identified that these computers need network interface cards to connect them on the network, so let us assume we have two computers. We have computer A with its network interface card. We have computer B with its network interface card. So this is computer A and this is computer B. So we use a cable, an Ethernet cable, to connect these computers. So we have an Ethernet cable that will help us connect those computers together using their Ethernet ports, which are found on the network interface card. So we use this cable here to connect those two computers. Now, when it is two computers, it becomes easier connecting them like this from the Ethernet port of computer A in the Ethernet cable. Then also you run that cable, and the other side you plug on the Ethernet part, the network card of computer B. It becomes that easy. And of course you do some configurations here and there within those computers, and you'll have a small network. Now, what if we introduce another computer, say computer C, and also another computer D? We introduce other two computers. So initially we just had two employees that were using only two computers, but right now we have added more employees. That means we now have 4 computers. So we need these computers to be workstations. They cannot be standalone because we need to share work. The idea of using this Ethernet port, Ethernet cable, to connect from one computer to another directly like this will become difficult, because we shall need to be able to connect all these computers in all so many ways. You see? So you'll realize that each computer will have to have 3 ports, 3 of these ports. But we also saw that typically each computer has about 1, unless you have another network interface card installed to have more than 1. But typically most computers come with just only 1 installed. Now, in a situation like this arrangement of just running cables from one computer to another directly will collapse. It fails. So what we do is we need a way of having a device that will allow us to connect from that device to these computers. And that device exactly is the first one that we are going to look at. There are quite a number of them, but the first one we are going to look at is a hub. A hub will help us network computers like this. You see? So there are hubs out there that can be bought. Hubs can be more than just, it can be USB. Sometimes you have USB, you want to use flash disks on your computer, but you realize that the USB ports are not enough. So you can buy a USB hub. But the one we are talking about is an Ethernet hub, and it can come in something like this. So this hub has 80 ports. So that means we can connect 8 computers using this one hub. 8 computers can be connected. There are 4 this side, 4 ports this side, and even the other side there are 4 ports. This is a typical hub. Now, when you use a hub to connect those computers, you'll come up more or less with a network like this. This is how your computers will be. So these blue lines are actually the Ethernet cables running from computer to a hub. Now hubs also have the Ethernet ports. If you look at these ones, these are also Ethernet ports, just like this one on a computer. It is the same thing, just like this port, the network interface card on a computer. Hubs in the same way have those ports. These are the same ports. So we can use this cable to turn from a computer, one Ethernet port of a computer, up to the Ethernet port of a hub, and in that way you'll come up with an arrangement that more or less connects all those computers together like this. Now sometimes it may not just be only computers. Now these are only computers. Even if you have a printer, you can add it to the network in the same way. So if you had a printer, you could also add it on the network in the same way, something like this, and that would help a lot. So a hub tends to simplify the hassle of us moving from the arrangement we had here that we were struggling with to a simple arrangement that you can have here. Or if you don't have other printers and only have computers, you can have an arrangement here like this. So a hub can help us do that. So within the hub, you'll see cables running like this. You'll see cables like this running. This yellow one could also be going to another computer. If you wanted another computer, you could run it from port 3 up to the Ethernet port of the computer. This red one is also going to another computer. So you'll have so many of them depending on the number of computers that you have connected on your network. So that's what a hub can help us do. Now, there's also an arrangement where it's possible for you to connect more than one hub. Such an arrangement would give you a network like this. That is if you have, because at some point you'll even run out of ports within a hub, and if you still have more computers, that means you can buy another hub, connect the hubs together, and like you can see, there are computers here connected to this hub. There are also computers here connected to this hub. Now, we shall have to describe as we continue. We shall learn that a network like this, or the one we have here, is just what we call a local area network. It is a LAN. So a hub is a device that connects a number of computers together to make what we call a LAN. LAN is just LAN, and it's called local area network. We shall talk about this in detail. I have just mentioned that, such that you get to know, to begin getting used to these terms as we keep mentioning them. So we have a network like that called the LAN. Now, how do hubs work? If you looked at this network, this one, this is how hubs work. If this computer wants to send a message to this other computer, the message that this computer sends is going to be transmitted to all the other ports of the hub, because this computer is connected to one port of the hub. That message is going to be transmitted to all the other ports of the hub. So that means all the computers connected to that hub will get that message. Now that's kind of hard to imagine, but it happens. When computer A sends information to computer B, all the computers connected to that hub will receive that message, even if it is not intended for them. So we have a scenario here where we have computer A, computer B, and we have computer C. We also have computer D. You see? And there's a hub in between here, connecting all those computers together like this. So computer A generates a message for computer D, for example. Assuming this is computer D, this is computer B, this is computer C. Computer A generates a message, and that message is intended, it could be, say, an email. That email is intended for computer D. When that email reaches this hub like this, what's going to happen is that email is going to be transmitted to all the other computers. They will all receive the same email. That's because a hub does not understand anything that is connected to it. It doesn't know, it will not differentiate. For example, if a message arrives in here, it will not differentiate. It is not able to understand that where is this message intended to go. So because it doesn't understand anything like that, all it knows is when a message arrives from one port, send that message to all the other ports. Also, if D replies the message, the email, say D has sent a response, that response will be sent to all the other computers in the same way like the message before will be sent to all the other computers. That way, it becomes very confusing. The network, the traffic, the way information flows will become very confusing. It will leave these computers with a task of identifying, is this message intended for me? So A generated a message for D. That message, even B and C somehow received the message. So B and C and D will have to do a task of identifying whether the message is intended for them. So B will identify if the message is intended for it, and if it is not, it will decline. C in the same way will identify if the message is intended for it. If it is not, it will also drop the message. Now D, who actually the message is intended for, will accept the message and send a response. And in the same way, the response is transmitted to all the other ports within the hub. Now that is a very disadvantageous thing, as we shall continue. When we continue to understand the network, you'll realize that that brings a lot of congestion. It is so confusing. Let us assume, for example, on your phone, all other people's messages connected to the same station, the base station that you are connected to, that your phone communicates with, all the other messages arriving at that station. You receive those other messages, then you keep discarding them, that this one is not mine, this one is not mine. It will be a very annoying experience. But that's what actually happens when you use a hub for connecting your computers on a network. All these computers in the same way will communicating that way. Even if you connect two hubs like this, information, if this computer decides to send information to this other computer, all these other computers on the network will receive that information. So that information, say this is the source of the message, it will be transmitted here, here, here. Everything, every port that has that, anything that is connected to that hub will get that message. It is not really a good experience, and it is the reason other devices were invented to solve things like those, as we shall see how disadvantageous that is. But that's how a hub works, and it's the way computers in a hub can communicate. That rudimentary way of communication is what happens in a hub. Now, there are two types of hubs. We have what we call an active hub. Active hub. What does this one do? When A sends a message, when it reaches the hub will get that message and re-amplify it. That means give it more strength. Probably by the time the message reached the hub from A, it was already weaker. It was a weaker signal. So what that active hub will do is to amplify that message and retransmit it. When the message will come from A up to the hub will give that message more strength before it transmits it to all the other ports of the hub. That's an active one. A passive one does nothing about it. A passive hub does not act like that. It just receives the message. It does nothing to the message. It just transmits it. Whether the message signal is weaker or it is not. It is not concerned with that. It just retransmits the message. Just like we had described before, that message arrives from one client and it is transmitted to all the other ports, all the other clients connected to the same hub, or in anything that's connected to the hub. They will all get that message. They will be the ones to identify messages for themselves and those not meant for them. Now that's how hubs work. Now understanding how hubs work is important for us to understand the next devices that were invented to help us deal with some problems that hubs could not handle.